Welcome to the SolidCAM University channel. This video's topic is translated surface. So the translated surface function is kind of one of the more classical toolpaths you'll find inside SolidCAM, and it's basically a way to machine the type of features you're looking at on the screen right now without having to use a 3D toolpath. Keep in mind that with SolidCAM, there's a lot of toolpaths that build upon it on themselves, depending on which module you've purchased or which package you've purchased. So this is one of the earlier toolpaths you'll get. This is not part of the 3D milling package. This is actually kind of a way to approximate a 3D toolpath using just 2D features. So let's get into it. So the way the translated surface works is, let me just open it right here, is we're trying to create a toolpath that's going to follow a surface such as this one. And you can see that I've created that right there, but I've actually created something simpler over here that we're going to use to start. And it works essentially like this. We're going to choose a path or a profile, and then we're going to choose the section geometry. So the best way to think about this is it kind of works like a sweep operation inside SolidWorks, where you're choosing the path and you're choosing the cross-sectional geometry. Now, with the part as is, we can't really use anything here. That is because the path geometry and the section geometry, they actually have to be in the same Z-plane. It'll make sense once I actually create the geometry. So I'm actually just going to jump out of here and let's actually go create that geometry, see if it'll make sense. So click on the feature manager, which brings me back to my SolidWorks functions. And if I had just 2D geometry to lay this out, which is what most people would have in this sort of situation where you're using translated surface, they would have the cross-section geometry and the path geometry in one sketch. They'd be able to just create this as is. But because I'm starting from a solid model, I'm actually going to do it a little backwards. So I'll go to Sketch, click on this face here, and I'm actually going to capture the cross-section of this right here. So I'll just create that with my convert entities, highlight that, and I'm just going to do a Control-C on my keyboard, meaning that I've basically copied that sketch. So again, keep in mind that this is more of a toolpath for when you don't have these 3D models, but you want to create a 3D feature. If you have the 3D model, you'll basically do it the way that I'm doing right here. So once again, I'll create another sketch, this time on this face, because this is actually the face where my path, my profile is on. And I'm just going to do a Control-V as in Victor to paste the toolpath. So I would like this cross-section to follow, let's say, this path right here. So what I should do is I'm just going to grab this, move it over here until they're coincident. So now I know that sketch is connected there, and I just want to clean this up a little bit by sketching it there. Perfect. So if we look at this in terms of the plane view, those are coincident lines. In terms of what we're going to do with translated surface, I want this to basically be right on the point that it's going to share with that profile. Close that sketch down. Just save that change. Let's go back to SolidCAM, and we're going to use those geometries. So we'll go Add Milling, Translated Surface, and we'll begin with the path geometry. So I just choose that one line right there. So again, the best way to think of this is like we're doing a swept solid or a swept surface inside SolidWorks. It works the same way. I start with the profile. That opens up my section geometry, and I'll pick the reference point. So this is the point that I would like to ride along that path. And then I'll go to Add. And we have similar functions you would see when you're choosing contour geometry. I'm just going to choose this one line right there. Green check mark. Another green check mark. So I have my path geometry. I have my section geometry. The side of that path right there, I'm going to have this sitting on the left side. Tool. I'll just choose my 1/4" ball nose. Levels will say upper level up here. Technology, very simple. This is a sort of a profile toolpath. It's just using that section geometry to kind of shape it a little bit. So we basically have the same sort of profile controls we would in a profile operation. One way, zigzag, if we're doing roughing, our overlap, our step down, and our finishing, how we'd like to do our finishing. And then in link, it's always the same lead in, lead out. I'm just going to switch it to none, and we'll generate the toolpath. So from those two chains, one representing the path, one representing the cross section, I get that toolpath right there. Okay. So let's do it again on this much more unique looking geometry. So again, I want a path and I want a cross-section geometry. So I'll go back over here, right click, let's go back into our design model. You can add the sketches anywhere you like. I just tend to put it in the design model, that way it's all kept in the same spot. So we'll go sketch, sketch on that face right there, convert entities, and I would like to convert these entities that represent the cross-section. There they are. Once again, we will click on Control-C on our keyboard to do a copy. Get out of that sketch. Open another sketch on this face right here, and we will paste that sketch. In this case, I have three edges, or three entities right there, 2 lines and an arc. If I were to try and move it, I haven't added any relationships to these, so I want to make sure that I don't actually lose that shape that I've created there. So I'm just going to do a very simple move entities. So I'd like to move those entities from starting this point right here, and it follows my mouse. And if I just zoom in, I'm just going to say to that point right there, but of course it's not locking because there's no geometry there. So just to kind of simplify it even further, I'll just make a little bit of a point right there. That point exists in this sketch as well. So now I should be able to just highlight those again, do my move from there to there. Now it should be locked into place. Save that change, exit out of the part, save everything. Let's go back and we'll create another translated surface. So we'll go add milling operation, translated surface. Again, we're going to choose our path geometry. So that one right there. Green check mark to accept that. Opens up the section geometry. We'll go to section geometry, pick the point we like to use as a reference point, that guy right there. And we will add section geometry. So just choose these guys here. Of course, I could have used my point-to-point, constant Z, same sort of functions you would see whenever you're choosing contours. So I've selected that. It shows us a little bit of a red line there, just showing us how that is going to sit relative to the path. I'll click the green check mark. And you can see right here, the default setting is left. I'm going to leave that as is, see what it generates. But we'll come back here, obviously, to fix that. I just want to show you one way versus the other. Again, we'll come back over here. I'm going to choose a 1/2 inch end mill. Levels, again, we'll do top face. Technology. In this case, let's do it as a roughing. So you see, as soon as I click roughing, we have a surface offset, and we've got our step down and our step over, or essentially a overlap. Again, link. Let's just switch that back to none. Save and calculate. So under the geometry section, we had it side from drive geometry on the left side. That's where all of that's gone. It should have been on the right side. So save and calculate. Now we can see that we have a translated toolpath. It's following that curvature there. To get a better idea on that, let's just decrease our step over. Okay. So in this case, overlap is actually how much the tool is going to overlap. So I put it at 80%. We can see that I've increased it. So it's following that curvature. If we take a look at that in Solid Verify, let's just slow that down a little bit. So essentially it generates a linear toolpath that just follows that sketch right there. So it's actually taking somewhat of a profile toolpath that follows the path and then just drapes it along that cross-sectional geometry. So again, this is kind of a one of the more primitive toolpaths from SolidCAM, but if you only have 2D geometry, it's very useful to create that 3D feature. Any other questions on this or any other topic, you can always watch the videos on the YouTube channel, or you can submit a ticket using the e-ticket system. You can always call us also at the tech support line at 1-866-975-1115, extension 2. Thanks for watching.